I'm currently the technical director of the Formula 3 team of Van Amersfoort Racing. The biggest names that we know nowadays are guys like Charles Leclerc and Max Verstappen. And moreover, Max Verstappen started his motorsport career in Van Amersfoort Racing. And from us, he directly made the step to Formula 1. The main job of an engineer in motorsport is, first of all, the guidance of the driver. And another important task is to set the quickest car for a racer on track. And that is where an engineer can make the difference. If he's able to set up a car, especially to the needs of the driver, that can make that little step from P5 to P1, what we are ultimately looking for. The margins in motorsport are very slim. It can be a tenth and a half between the top 10 of cars. If you don't innovate, you're standing still, and standing still means that you don't win time compared to your opponent. So for us, it's very important to keep innovating. Currently, we drive with Formula 3 cars, which are homologated, so we cannot change so much on the car. But to still make that innovation, we can do a lot around the car that we can improve. So we can make all processes quicker, we can enhance the performance of the processes, and for that, we can use additive manufacturing. This year, we made the step to drive Formula 3 with Tatu's cars. And actually, we received this car only 2 weeks before the first race weekend. The car arrived here in the workshop. We had no tools, we had nothing, and within 2 weeks we had to prepare ourselves to participate in the first race. And that is where additive manufacturing helped us a lot, because with that we could manufacture parts or tools that we needed within 2 days. And that is something we could never do before with metal manufacturing. It seems like the philosophy of 3D printing has been growing up a lot within the company, because it happens more than often that, for example, a mechanic comes towards us to say, I miss a certain part to fulfill my job perfectly. He knows exactly the requirements that he wants to have for that solution, and within a day we already have a part for him available that makes his work easier. Our cars, when they operate on track, are exposed to extreme conditions, and given the open filament system of the UltiMaker system that we use, we are able to look for materials that can fulfill the need that we want in those extreme scenarios. For example, heat resistance, extreme stiffness, but also durability. So we started browsing the UltiMaker marketplace, and we came across a company called Clariant, and they could help us find materials that could exactly fulfill the need that we would need from these materials. We also have applications that require a certain stiffness. For example, the rear alignment tools that we use during setup needs to be pretty stiff, because when we measure certain aspects of the car, we measure within tenths of millimeters, and therefore we have a high requirement on stiffness on the parts that we use on the car. In order to achieve that stiffness, we used carbon fiber reinforced materials, and that fulfilled exactly the stiffness requirement that we've put for this part. They also could make our specific orange, and that really helped us to make a professional look into the tools that we have nowadays. I think the direction we went into with whole 3D printing helped us a lot in optimizing the processes, and I think we have to continue elaborating the possibilities for us to make sure that all our systems can be optimized even further, and therefore make the workload easier and make sure that we can stay on top of the innovation within motorsport.
A unique adapter plate for every single microscope in serial production. My name is Johannes Grimm and I'm responsible for the operational excellence team at the Carl Zeiss Optical Components. We are producing digital microscopes, different multi-sensoric machines and optical sensors. And this microscope is measuring machines of flat parts. You can measure features like circles or distances for industrial quality assurance. The adapter plate in the digital microscope is used to align a specific foil, which is necessary for a very good measurement. Because every foil is unique and therefore every microscope has a unique 3D printed part inside. We make a lot of these microscopes. We choose to 3D print that part because for the assembly process it is very stable. It's much cheaper than a traditional way with bracket and adjustment screws. And for a customer, and that's the important thing, is for example for a replacement of a spare part, because they have only tightened a few screws to replace a very important part, and then he's able to operate again. This was expensive, around about 300 euros per machine, and with this new way of manufacturing we are able to reduce the cost to 20 euro per part and saves additionally a lot of money. With the help of 3D printing we are able to decrease the lead time from months to days. Because of these decreased lead times, you are able to do more cycles and therefore the quality is also increased. Also UltiMaker is chosen because these machines are reliable and the results are repeatable. That's important for us for a stable production process. Nowadays we see an increasing number of individual machines for individual customer needs, and 3D printing helps us to meet these individual requirements from our customers.